The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people are evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I am geologist Philip Ong, here with Mr. Dane DuPont of HawaiiTracker.com, bringing you guys another Kilauea and a little bit of Mauna Loa volcano updates today, Friday, April 1st, 2022. We've got a lot to show you guys today. It's been a lot going on. Thank you guys for catching us one day later than usual. Normally we come in on Thursdays, today we're doing a Friday because we had a special meeting yesterday with our community. And we're going to try to catch up on the last week of eruption for you guys, which if you guys see the cycling on screen here has been very active on the surface, pretty widespread activity all over the place. We've had no pauses in the last week until it appears we have a deflation-inflation cycle beginning now, and so we'll have to wait and see if that'll mean another pause coming up now or possibly a lull without any stop in activity. We'll see. But really the whole last week, no pauses, lots of activity, lava flows across the whole crater floor, spatter cones you can maybe see here in the foreground. So we'll talk about all of that and start off by sharing a bunch of our viewer videos of what you can see from the national park. So as we go through that, we'll discuss your questions, of course. So submit your questions through the chat to Dane. We'll have a discussion out there with you guys as we go along, and collect some for us to discuss live on our broadcast as well. And also let them know if you have any issues with our audio or with our video or anything like that, as this is our kind of I'm not sure what to call it. We're not exactly a pirate production here, but we're like a low budget production here, so just making sure if you guys want to support us, make sure once again like, share, and subscribe. That's the best way to do it. All right, so that's the view across the floor from the B1 camera, which is the one we've had newly restored from the east side of the crater. And we'll switch it here and we'll advance, and I'll show you guys the next thing, which is that similar view from the F1 camera. So we're looking at just the past week here, and that former camera, the B1 camera, was positioned more over here, and it's looking more in the opposite direction this way. So we're looking at the activity in the foreground that was over here in this camera now. So now we have our view that we're perhaps more used to, that's looking from the west. So our west vent complex is over here. And there's that original cone right over there, and you can see that new pond complex is over here with our active persistent lake right in here. And then our bay that had our lava falls is right over here as well. So all this other stuff on the outside is all ooze-up flows around the perimeter of the crater, that inner perimeter against the crater wall, sometimes inbound of that. You can still see a little bit of this line of cracks that goes around that marks the edge of that crater, right? And in the past, we've drawn it actually right here, but it seems like perhaps it's widening a little bit and expanding. And so the best way to show you guys that is if I pause this and then just drag it back and forth real quick. It's just a past week, but even in a past week, you can see this fairly significant uplift of the crater floor here coming in. What I'll do is I'll advance now to show you guys the whole last month from this F1 camera, and it's sped up quite a bit, of course. But you can see here how in that earlier first 2 weeks of the month, we have a few ooze-up flows in the perimeter, and we have some lulls occurring with the surges coming out of that lava lake. That's what we're used to. And then more recently, here's our more recent surge and an activity all across this eastern crater floor, the northwest crater floor, the southern crater floor off the image over here to the right, kind of all over the place, really. The pretty cool stuff. And so here I'll once again drag it forward and back so you can really see the uplift of the crater floor in the last month here. This is one of the fascinating things. I show it almost every week here, but it's still amazing that it's going on at that similar rate and coming up. And as we've been teasing, the eruption rate over the last 2 weeks appears to be close to double that of the first 2 weeks of March. So we'll get to those calculations here in a little while, but we're first going to show you guys some of this video. After I just quickly show you these first graphs, we do have our lava depth plot back online from USGS. Mahalo USGS for that. And it's been recording for just over a week now. And what you can see is the lava level has been rising with a few peaks of surges. This was that big overflow surge on the 26th, in the morning of the 26th. And you can see a couple other little steep rises. Here's one on the 27th, about a day later. But overall, the general trend is an increasing line, right? And it's rising from 331 meters to not quite 337 meters. There are 6 meters within the last week, which is a huge amount compared to what we were seeing before. Now, of course, like that's just the spot where the laser is pointing, which might be on that bulging part of the crater floor. And so it's not clear exactly that the entire crater floor, all the way east to west, is rising at that same rate. But certainly where this thing is pointed it is, and that's pretty impressive. And what's been interesting, unusual, is that our ground tilt, which you can see here in this plot on the bottom, has actually been moving opposite of our lava depth, and that's different from what we've seen in the last few weeks, few months, in fact, right? So what we see here is the beginning of this most recent deflation-inflation cycle right there, and we're going to wait to see if we'll have a drop in the lava level or not, and that's our big question mark over here. But you can see that this previous decrease had no effect. All this downward trend for the last week has had no effect on this actual oppositely trending, increasing lava depth. So that's interesting. It's a little bit of a conundrum. And it could be that it's more of a localized signal, or there could be that some of the pressure is going elsewhere, like perhaps into upper parts of the rift zones, other parts of the summit reservoir underneath the caldera. There's all kinds of options of complications that can occur, and it seems like there's some complication occurring here because we're seeing this disconnect between these two graphs here. If we go back to the last month, you can see it perhaps a little more clearly. It's not as easy because of this big data gap. We don't have any data from this plot, but we do have about a month ago, if I zoom it way in, perhaps, right here. We had a lava drop and then rise again. That's kind of the pattern that we were seeing before. Drop and rise again, and lava level corresponding to the deflation-inflation events. I zoom it out, you can see that we hadn't had these two deflation-inflation events at the time. That's when it was tied together. And somewhere in this gap right in here, you can see the tilt had been kind of flat for the first 8 weeks of the month. And the last 2 weeks has actually increased, and perhaps it's flatter now in the last couple of days, right? But certainly the increase was visible over here. Did have these deflation-inflation events here that occurred, but none of these seem to be significant enough to really stop and pause the entire eruption, really. So we really didn't see much of that, as you could see in that F1 thermal I just showed you guys for the whole last month. We had a few slowdowns, especially early on here, but more recently it's been less and less so, and more what we've been terming the lulls, right? The decrease in activity, but still visible within that pit. And we've wondered whether that could be a change in the connection from below, whether it's coming up more easily, or exactly what's going on there. And so this is one more variable and thing to consider, right? And I will note that it's been about 10 weeks, not quite 3 months, since we started seeing those big, deep earthquake swarms underneath the Kilauea caldera. And so we got to wonder if perhaps there's just some increase in supply rate from below, or something like that, that since we know that those deeper parts of the volcano are in play as well. Okay, not to get too carried away with the technical stuff there, just pointing out this overall trend of lava depth is still increasing, maybe a little faster recently. You can't really see that from this graph though. So what we'll do here is just check in for the last 24 hours, actually the last 17 hours on this F1 camera. That some of these cameras are going down once in a while, so it's back up since midnight, it appears, and you can see that corresponding to those tilt graphs, it's been a little quieter in the last couple of days. You can see that these flows on the eastern side of the crater are still active and oozing, but they're not nearly as bright in color and as extensive as they were in the last few days, last week or so. Still having an ooze up here close to the camera on this northwest part of the crater wall, and still having lava within a lava lake and filling that pit to the southeast as well. We'll look at all this here shortly in our videos. All these different features in here. So everything is a little quieter as we presently speak, and we're awaiting the impact of this big deflation that just began today. Okay, so we're going to go through a series of videos now and kind of recap this whole last week and all the different phases of viewing, because it's really been a spectacular, noteworthy week of eruption viewing in the national park. We showed you guys that persistent lava fall video last week that we put together from viewer videos as well, and the time-lapse cameras. But we do have this USGS video that was released also of that lava falls area, with the little archway it's flowing under and filling that pit, and it looks like the pit is actually, you can see it's circulating clockwise here just because it's pouring in on this upper side right there. So it's almost like a little whirlpool, a little lava whirlpool down in here, right? And that's interesting to note because as we've noted, this thing doesn't spill over unless the amount of lava coming into it is huge. It actually does find some exit point. There is some drain down here somewhere.
That's a pretty well-defined lip there too. You don't see like the rings of a tree going up where it's fluctuating regularly. At least I don't.
The lip on which part of the lip are you talking about here?
On the pool on the bottom, the lower pool,
bottom,
where it's
like on this right
going
side.
into, yeah,
Right over here.
right,
Yeah.
and it looks like that's pretty pronounced, and so it seems to me that it's been consistent.
Yeah. So yeah, if the rate coming in and the rate going out match, and you can form those kind of benches, yeah, absolutely, yeah, it's a good observation. And of course, part of what's helping that happen is the spattering that's occurring, right? The spatter that's kind of splashing up and going along the walls and helping to form that cooled lava bench. But also the lava, you can imagine, is probably churning beneath the edge of this thing, and it's probably undercutting it and perhaps eroding it, right, with its heat and its physical force. So that's pretty cool to look at that as well. We've talked in the past about lava tubes and whether different kinds of erosion in tubes, and it's the same kind of processes you see right here. So that's pretty cool. And while we're talking about this video in this level of depth, it's cool to see this big pieces of crust up here from this main part of the lake are dropping down. You don't see them actually re-emerge down here, so it seems like a lot of the stuff is getting stuck or impacted somewhere under this bridge over here. So pretty cool. This is how it was last week. We're kind of just stepping back to recap what was going on last week here. And likewise, we have a video from our viewers, Two Pineapples. And this is showing gas. I'm not sure. We've called them lavados before. We've called them whirlpools of gas. You can see the spinning gases here ripping up the crust of the lava and flinging lava into the air. So pretty cool to note that. This is from back before this this increase. And we'll advance it here to show you guys a clip from Epic Lava on the 26th. And 26th is the day of that larger surge, right? And so let me go back here and just play this original video that we had, and the surge is coming back over here and it's flowing around over here from this main lake, right? So this is kind of the part of the week from our B1 camera. Let me let it wrap back around, pull it back, and you'll see the beginning of this, and that's that ooze-up flow on the side, and there is that big overflow right there that we're talking about right there. It's occurred. So back to it here. And that was that bump we saw in the graph. We're zoomed into, that's that perched pond area. This is that channel entry, right, where we just saw that whirlpool right over here, and you can see this line of cones over top of the spillway is all spattering. That's pretty cool. We haven't seen this as active as this. We really had to have caught it at the right moment. So mahalo, Epic Lava, John Tarson, you guys, for sharing this. And we're going to do a little tour here across the crater. Kind of zoomed in. You can see the lava's circulating down all the way to this bottom right corner. That would be like the northeast branch, and it's kind of diving back in there and spattering. There's spatter here along this closest to the bottom, this eastern kind of exit point of lava in the lava lake. It seems like it's diving back under, and what's happening is as it dives back under, the gases then pop back up and cause all that spattering above that zone. So not only that, oh, here I got to rewind because I talked through the important part here. So there's our spatter at that eastern edge, kind of the bottom of the view when we're looking from an overlook in a national park. And it's panning to the left. This is the area where lava falls used to be, right in here. But now we have a big rapids over top. The entire pit is all the way filled. It is also overflowing and sending a big huge mass of lava flow over here towards this southern part of the crater floor here. And so kind of panning over, you can see this edge of the collapse block over here, lava all the way to this far edge of the crater. You can see lava is oozing up all around. The main vent itself, you can see flows and some spatter coming from it. The fog coming and going, blowing in away the fume. And we'll zoom it out here for you guys to get a view of what that looks like. During the height of activity, you see lava within that whole side of the crater, and quite a bit of other area that's still fuming and hasn't quite picked up by this point in time. This is the 26th when that first surge occurred there. Here's the next day on the 27th from Two Pineapple. So we'll zoom back in. You can see not quite as much activity. It's a little bit more subdued than that previous day. But you can still see that lava is filling that entire pit. It's still draining down in there somewhere, and that's causing that bubbling, spattering pit over there on the left. That line of cinder cones still spattering a little bit, but not nearly as active as it was that previous day. You can see lava still spilling from this upper pond through the spillway down into the main pond. And we'll look at the V1 camera and the evolution of this whole zone after our first mid-broadcast break here. So we'll leave that part for a little bit later. But noteworthy that where that lava is draining out of that pit, there is that bubbling spot there. That's kind of on the left from the view of the Kanikakoi towards the southeast, and there's a zoom out so you can really see where that fits in. The original west vent cone is glowing up in a fume right up here, and then that pond is more over there. So that's a little bit of an orientation and take you through what you could have seen some different days of the week here. Mahalo Two Pineapples for that one. We'll go through some of these other videos here, and then we'll maybe see what questions are popping up here. But next, we'll turn to the USGS video. This is a video that they've reported as from a webcam that they've deployed, and so this might be a webcam that's perhaps coming on, or that we will have to link to at some point. But right now, we just have this video clip of it from the 29th in the evening here, and this is on the eastern part of the crater floor, and it's showing a spattering cone right here. So it's just showing that the lava is still filling underneath that that solid darkened part of the crater floor, and it's still pressurized enough to be popping up through the weaknesses in that crust. And it may largely be about the gas trying to escape, but when it does that, it's sending out this fireworks show of lava as it does so as well. So I've used the analogy many times before. The volcano is kind of like it's trying to burp a baby, trying to get the gas out, and the lava kind of gets stuck in the way. And that's because the gases are bubbling out of the lava as it's rising from depth, and as they rise, they get bigger and wider and bigger, and that causes them to just vent out. Whatever's in the way gets carried there too. So, do you see a question coming in for the gas composition? We haven't had a report of that actually, but I will show you guys. There was a sampling of the Kilauea well recently, which is another part of the gas equation that we like to look at, how the water table is responding to the sulfur in the lava as well. So we will let me keep going in these videos here. I see you guys got some good questions coming in, but let me stick with it.
We also did have the other day in the Loris Rift where the rain and everything got it nice and smelly again. So you could smell that H2S on the air. Wonder if that has a little bit to do with anything.
Yeah. Well, let's talk about some of that gas possibilities in a little bit. Let me kind of finish the summit story here, because this USGS video taken from the south is showing some of the features we've been looking at from different angles. Here's that zone of lava's flowing in that northeast zone, and it's actually recirculating down here, and the spatter's coming up, right? So you can see as it spatters, it builds this little spatter cone on the rim. Now we're panning over to, not sure if it's the same cone on the east side of the crater floor or a different one, but now it's pouring out lava. In the center of the crater floor, this big pool of lava, see, it looks like solid ground, but this entire thing is a lava pond. And as this video progresses, you'll see the whole crust overturning and the liquid lava underneath replacing that very, very thin crust there, and starts to reform it. You see it turning gray here on the left side as it propagates across. So this is from the USGS point of view, right? So they, everyone, of course, these are all big zoom cameras or zoom telescopes that are being paired with cell cameras, that kind of thing. So you really want to bring binoculars or something like that if you're coming to the overlook to try to see these things. There's a lot happening, and it's across a huge area, but it's still a long ways away from where you are, and it does help to have something to magnify there. So here's a still photo of that similar area we just saw in the video, that zone where lava seems to be flowing that way and exiting somewhere down. So we have a spatter zone here. There's a second zone right over here that we showed with the video as well. A couple more spatter cones on the edge right over there. You can see this big burst, right? Another exit point right over here. And then the third one is the one that goes across the lava falls into that pit. And so there's 3 exit points that we're seeing here from this lava lake that's active and persistent. On the 31st, from 2 pineapples, this is a view from the overlook. So there's that middle point right here. That's that middle spatter point, middle exit point. There is the exit towards the pit. Now I've sped it up so you can really see the circulation a little bit better. You can really see how it's coming, moving over this way to there, and it splits and goes that way as well. Zoomed in once again on that closer spatter. That's one of the things that most viewers can see a little bit there in the foreground. It looks really tiny, of course, but it's very bright and hard to miss. And so mahalo to pineapples, mahalo you guys for sharing these views with us here. I especially like this one here, that lava pouring into that northeast exit point, and it's just spatter bursting over and over and over, and just think it would run out of gas at some point here. Just keeps going and going and going and going, so pretty cool. We're just clipping a few seconds from these 2 sources. They're streaming sometimes for hours up there, so you guys can make sure to check them out on YouTube as well. Okay, that's the 31st. And to round it off here and summarize the viewing from that Kanekakoi overlook, here is the S1 camera from the south, right? So reviewing the whole last week here. And there's a little bit of a pause in there because the camera does go offline before that surge. And of course we're cut off. Here's our central main island right over here, and you can see that just the edge of those central flows in that pond that overturns right over here on the right side of the screen. So most of that's off camera, which is why we started off with a B1 today. But you can still see here that overall pattern at the very beginning. If I put it back to the beginning, or let it loop around, and zoom in on a pit here. exit points. Screen here. So you can see a filling there from that archway at the beginning, pauses, big overflows all across. Yeah, you can see those big rivers coming down all around. Pretty cool. Lava behind the vent over here as well, back over here. Vents itself are changing and moving. Big flow over here on a bottom part of this image that's kind of obscured by this cliff from this camera view. But since you're looking from the overlook more in that direction, you can still see a little bit of this lava on this side sometimes, including what we showed you guys from Epic Lava that was way back off in that corner way over there. So really a lot going on all over the place here. Checking in on the S1 camera, let me give it a reload. Get a better lit picture here. So current conditions. If I zoom it in, I can see a little bit of this lip, this dark edge on this image, right? So it seems like the lava level is still, it's below the rim a bit, right? So it's not been overflowing as much today, a little bit earlier, but it does appear like it perhaps is dropping slightly. And this is what we'll keep an eye on, is how high that becomes over the next 12 hours, perhaps, to see what effect there is lava levels with this here. So, okay, I do see some questions about the viewing and the overlook. So let me make sure I cover that a little bit here. Here is a USGS view of that whole crater floor from above. So the viewing area is off to the right still here, but this kind of gives a big overview of what you can and can't see, right? So what you can see from that overlook is essentially all of this stuff through here, and there's some point in here where you can't see this foreground because it's behind this cliff right here. You can see this main central island. You can see all the lava flows over here. You can see lava all the way over here. You're kind of missing a chunk kind of back in here like that. This is aerial photograph from USGS. Shows that old road, and then the overlook that we have is off of this road further up the way here. So here is the park map, and we're just looking at that crater right here, this caldera, right? And so almost everything we're showing you guys is from this Kīlauea overlook south right over here. This is close to where it is. I'll show you a picture of this already now, but of course there are other spots you can see. Waldron's Ledge here in the east, you can see the top part of that eruption, not as much of that, really just this back part over here. From this area between Uikahuna and Kilauea overlook, you can look down and see the zone more or less in here. Not the vent itself, but as the lava level keeps rising and rising, it's going to become better and better from more and more places. And so we'll keep our ears open for you guys to share with us if you're seeing it from somewhere else. Just let us know for sure. Okay, so there is a USGS photo here. This is showing, looking away, we're now the lava lake's behind us. And this is Kilauea crater back here. Here's the main caldera floor right in here. The downdrop block begins kind of right in there. So the lava tube is back in here more or less. Some more in here. So people who are visiting the national park would drive past the lava tube, they drive all the way around, and they try to come and park over here at Devastation Trail, which is this area right in here is where the parking is. And so if you're wondering about what the walk actually is, essentially you're walking from this parking lot on this old road, which there's no vehicle traffic on it except for rangers. And you walk all the way to here, and you come to this branch off, you turn there, you come down, and boom, here you are at the overlook. I pan it up a little bit. See, there's like a little bit of a cinder pathway off the road, and kind of flat here, and then it gets a little bit slopier towards the bottom right over here, right? And this is avoiding this big fissure from 71, 74 complex right through here, both sides. There's some fissures here. There's, in fact, that's where the old overlook, right? The original Kīlauea overlook is down here. So normally you would have kept walking further down and then come over here to this area. But this is all designed to look at the fissure. You can't see the eruption as well, but it's certainly worth coming over here to look at into Kīlauea crater. This other crater in a photograph right over here. So pretty cool volcanic landscape, right? 3 craters, viewing areas, roads all through here. I didn't point out a chain of craters actually begins here and goes off in that direction, the East Rift. Off like that. You can see some of those cinder cones all the way down there, like East Rift going all the way down, but with some blockage still existing around Pu'o, we believe, somewhere in there. hard to tell from this picture without zooming it in more. All right. In a national park, of course, check the park pages for their advisories and conditions. Gas conditions have been fine up there, and fog forecast has been blowing the gas here to the southwest for the most part. But there have been some times of there have been some kind of stormy winds that have blown fog elsewhere. So perhaps that's part of it as well. As Dane mentioned, there's been rain, so the rain could be adding more steam to the shallow ground, and if it's that is able to maybe carry that smell further, right? So that's a possibility there as well. But the last thing I wanted to mention, and it's not exactly shown on this plot here, but I'll get to it. The gas data, SO2 coming out of the volcano, has been in this range of a little bit lower in the last month here, between 2,200 tons per day at most. Let's see, right? And of course, during those lulls, it can be down, less than 1,000 in this case, because we've had more lulls than we've had pauses. You can see down to 1,400 or so. Right, that's that main integrated measurement of all SO2 from the volcano, and we have ambient stations all around that are showing that pattern too, right? Still gas coming out. This is very weather dependent, blowing around. You can see that in one station, the wind will blow it in, blow it out, blow it in, blow it out. So even across one day, it comes and goes and comes and goes. And some days it peaks higher, is worse than others, right? And it kind of varies in a lot of those conditions there. But what I want to get to here before I stop and talk about that question again is the USGS report here, which adds one more data point, which is that there is an SO2 measurement rate of 3,100 tons per day on March 31st yesterday, reported here as well. So look at their plot. Where'd my SO2 go here? 3,100 would be off the top, off here somewhere, right? So it's a little bit higher than it's been in recent weeks. So finally, I've come around to the one piece that I wanted to add to that answer there, which is the combination of this maybe slightly extra amount of gas coming out that might correspond to this extra amount of lava coming out that we have going on here too. So let's see here. We're having some good questions. The first one, we'll have a better break for more questions. Let's see if there's something that fits in right here. One that I want to address right off the start, is a question from Ken Staggs. At its current fill rate, are there any concerns from the volcanologist community? Not really. The lava is still filling within that pit. There's plenty of space for it to fill, as we'll show you guys in our back half of our broadcast here, when we do the projections of how far this thing is going to fill and how fast and all that. So we more worry about the underground changes that open new pathways to other areas, which can happen kind of separately from whatever's happening on the surface and the lake filling. So lake filling is kind of a passive novelty. It's cool. It's great viewing. That's why we keep seeing this as the best time for viewing. And at some point that'll change. It might be a small eruption on a little rift zone close to the summit, perhaps. There's still no signs of it really going anywhere else and changing anything else at this point in time. So similar to another question here from Sonia, lava was dropping and filling up and overflowing at the old crater. Will it happen again, or will it exit out another area of the island? Pretty similar to that as well. So right, it's the underground changes really that we need to consider there. All right, so anything else you want to throw in here, Dean, before I wrap up our projections and filling rates here?
We'll just save them for the first Q&A session.
All right. Okay, so we'll do the filling rates first here. We'll do projections a little bit later. But what I wanted to point out is in today's update, April 1st here, and it may have been on yesterday's as well, I believe. We have a new reported volume of lava here of 64 million cubic meters, or 17 billion gallons, measured 2 days ago, March 29th. Right? So 64, 29th, right? So there's a reason this matters, is because the easiest way to show you guys is to kind of plot it. We have that volume. We have this map that goes back to last week, statistics through the 17th. Right? And if I zoom this in here or blow it up, you can see the volume last week was, we'll call it 58 million cubic meters compared to 64. So 6 million cubic meters in 12 days is what we're looking at here. And we had another value actually reported on March 2nd as well. So it turns out that for the month of March, we have pretty good coverage as far as our volume reports here. And here is what it looks like. So once again, this plot is showing total volume on the left in millions of cubic meters. So The red line is our current eruption. The blue line is a previous eruption that we've now surpassed, right? I maybe could have mentioned this sooner. We're now just past the 6-month milestone of this eruption. And no signs of it petering off like the last one did after 5 months. Instead, it actually seems to be shifting into another gear a little bit here, right? So these are just the total volume measurements, and I'm sure it's harder to read that unless I zoom it in a whole bunch. So I'll zoom it in here to the right side of this plot. And here's our 64, 58 12 days ago, and 54, I want to say that was maybe 14, 16 days before that, right? You can see that just from the slope of the line, it's a bit steeper than what we had before that, right? A little bit of a gap through here, so maybe some short-term variations that you can't tell. Still, the rates increased right here, and we can actually do, from these intervals, calculate the volume coming out per second. I've done this before. And here's what the plot looks like, and it's all the way here on the right. I'm going to start off by zooming into the right here. I'll come back to what's on the left in a second. But here's our value, 6.1 cubic meters per second is what I got calculating from those 3 maps there. The previous value for the first 2 weeks of the month was 3.2. And so that was kind of normal, right? And we've been at these greater than 1 values for a while. Maybe a slight increase, but nothing you could really say conclusively from 2 to 3 there. But 3 to 6 or 2 to 3 to 6, this now seems like more of a real trend that we're seeing here, right? And 6 is still a very low value. This is what I'm going to point out the left part here of the graph. We began with this eruption peaking over 129 meters per second. This is the red plot over here. The last eruption peaked at 110, and both eruptions, as we can show here, very quickly within the first few weeks dropped off their eruption rate to these lower levels, right? And you can see that really it's not a high rate that we have at 6. It's still a low rate, but it's just higher than it's been for the tail end of the eruption there. It's really nothing compared to these first phases that we see up here. Just like a little bump here at the end, but significant when we're scrutinizing it week to week to week here. So what else can we see as far as this buildup in the volcano here? We've mentioned that's a little bit weird with a tilt. The tilt did show an increase a little bit over the last 2 weeks, and then not as much now. And the increase, I maybe could have pointed out here, is only from maybe a little less than 0 to a little more than 2. So we're looking at 2.5 microradians at most. It's not a huge amount of actual inflation here coming up. So this is still a question mark. But looking at the 1-year GPS north to south here across the caldera, we can see that over the past 2 weeks, it does appear we have a little bit of a steeper rate of spreading. So that seems consistent here, right? And we've seen these little down and up wiggles and this variation when we had more deflation inflation events, and that's what I suspect was happening here perhaps. But it does appear that we now have enough data to corroborate that eruption rate calculation there. A little bit of data missing here at the very far right end, but that'll probably catch up at some point here. Now if we scroll down to the Pu'o'o length across the East Rift Zone, it's kind of a combination of 2 factors. One is, possible magma filling into that rift, and 2 is the south flank moving. And you can see that the long-term pattern for the last year, there's a lot of variation. But recently, since this eruption began, it's been a long-term contraction, right, of that rift zone, right? We've had a few little deviations, like right in here, perhaps, that first part of the eruption. And here at the very right bottom side, we're starting to see a little bit of a different pattern, and perhaps it's a short-term trend adjustment because we've mentioned that there's both south flank adjustments, right? And the south flank perhaps can lead to these kind of little interruptions that then later resume. So we have to wait and see what happens down here at the bottom right. Or there's a possibility that we have a little bit of lava starting to trickle into this rift zone as far as Pu'o'o. We don't see this anywhere past here, and there's no signal, and it's nothing evident on a tilt or anything like that. So if there is anything, it's really got to be marginal, and it's really not, I hesitate to even say that because there's not a lot of evidence, but I know that someone else is going to say it, so I want to just put it out in the open here that there's a possibility there's a little bit going in there. It's not going to be that much. It doesn't seem to be changing any of the other signals that we're seeing, whether it's gas or tilt or anything else. And so this is possibly still a south flank induced situation here, right? And I will point out that we have had on the south flank in the last few days here, magnitude 3.3 earthquake. Right? So it does show signs that it could have been stuck a little bit, and maybe it's resuming. So once again, we have to wait to see what's going to happen here at this right end. But a little curiosity there, a possibility that magma could be filling other parts of the reservoir. You know, even if it's not so much here. Certainly under the caldera, there's a lot of other areas that can be pushed apart. Okay, so we're going to do the earthquakes and Mauna Loa, and then we'll do a whole bunch of questions. So as far as earthquakes under Kilauea, it's been pretty steady here. Right? This is the peak that I referred to 10 weeks ago or so. That was a deep earthquakes underneath the caldera, and perhaps wondering if there's some connection of that feeder source finally propagating that pressure up to the summit. And that seems like I'm not sure exactly if that's a reasonable timeline or not, but that's how long it's been there. Yeah. Over the last month, some variations a little bit here and there, but nothing really significant worth scrutinizing. Here's that bigger earthquake under the south flank I mentioned. I want to say it was a 3.3. Otherwise, a little bit under the summit. Pahala still doing its thing. South flank still expressing at these low rates here, low magnitudes. So all that's normal and all that's good. If I come down here to the last month, you can see a little bit of more of the bigger picture, and you start to seeing these blues and purples all around here, right? Pahala, of course, is bigger as well, but this is still a little bit of that deep earthquake signal still coming through underneath Kilauea summit. It's visible in the last month plot here. Not so much visible as far as changing rates or all of that. So all good on the earthquakes there. It's really not a whole lot, but we got to cover them. As far as island-wide earthquakes here, you can see we were just focused on Kilauea there, and Kilauea is pretty sparse. That's the one 3.3 there on the 26th. Depth of 6.7 kilometers. That's right in that south flank area. Not a whole lot in the summit. Pahala still going off, and maybe we see something, you know, if we look at the largest magnitudes in our plot here. The largest one is a 3.7. The Pahala quake. And then the next one is actually a 3.5, and it's a 3.5 above sea level, so it's within this bulk of the volcano up on the side of Mauna Loa right here. And so that's something that's interesting to look at. I will say right here, right now, there is no eruption on Mauna Loa. We have seen multiple April Fool pranks posts of reports of eruptions in Mauna Loa, and multiple people getting triggered and traumatized by that. So everyone's doing their own thing, of course, but that's what we're seeing happening in our community here, is that people are getting very, very upset about those kind of pranks. There's no eruption happening up there. There has been an earthquake that occurred on 29th here a few days ago, but not really changing anything on the surface there. So we can look in a little bit more detail at that. And one thing to note here is that Mauna Loa report for today says there were 65 earthquakes beneath the summit upper elevation flanks, but in total, 217 small magnitude earthquakes under the mountain. So there's a lot more this week under the flanks as well, right? So that's something that's to consider. The flanks are moving. We know there's earthquakes under the summit. If we look at the earthquake rates over the last year on Mauna Loa, we're still at low values here, right? This is when the mountain started to seem like wake up from its slumber there after some recent kind of lull. It's kind of gone back into that lull, it seems like. Now, maybe waking up from it again here as we see the flanks start to spread. Earthquakes over the past week. Here's that little cluster, the shallow cluster shown by red. We've had this very similar cloud to the northwest is always active, and it usually, when this one and this one are active, it usually means magma chamber is filling and kind of pushing on the sides here and here. It's kind of the normal places for it to quake. And it seems like if we're seeing the flanks also showing earthquakes, and that's not shown on this map, those 65 are just in this little plot, and so is this rate right here, right? So if we look at where's 217, it's not on here. It's because this little plot only counts what's in this square near the summit of Mauna Loa. Which is why I wanted to make sure that value from the report. So the flanks were still quaking, the summit's still going. Here's a whole last month on a summit. And if I can scroll down here, you can see a couple of deep events way down as well. Nothing connecting them, but interesting to see deep events under Mauna Loa as well. So on Kilauea, we saw a couple of these, like maybe 3 months ago, and then after a while, we had a swarm that was deep, and then that was the real signal, more so than these kind of one-offs that you see through here. Interesting to note that they are also active there, the same time as they're active under Kilauea. It's kind of a curiosity there for seismologists to investigate. Okay. Over the last month, we can see a lot of natural variation here, but nothing quite alarming. There's nothing indicating any eruption, of course. And here's our GPS across the summit, right? So this is what I described as that long lull the volcano has been in. The summit's not expanding so much across its north-south axis. Moves up a little bit here, and then we start to see this little adjustment zone right through here when those earthquakes occur. So we're still in this kind of scatter zone. We're not quite climbing. We're not spreading again, as we can tell. But it looks like we're adjusting by moving pieces all in different directions, right? So kind of like a spreading. It's just, of course, just scatter and few stations right here, right? But that's kind of how I think of it across. Okay, we'll show you a different view of Mauna Loa today. Here's from Mauna Kea looking across the saddle, across the receiver antenna here. Big view of Mauna Loa. Mauna Loa is quiet, nothing happening, no gas, no eruption, nothing like that's going on. All right, so I think, Dane, that we are to our first break, and we can say some thank yous, do some questions, in whatever order you see fit.
All right. Well, let's start with some thank yous. Thank everybody that tuned in today. The likes, subscribes, the shares, the comments, all that stuff really does help with the algorithms to get this seen by more people. A comment left after the stream ends really goes a long way with the algorithm, and we appreciate everybody doing that as well. We do also post everything on hawaiitracker.com, so if you want to go there, there's a comprehensive chronological order of the posts that we've been doing. You can also make a donation there if you are so inclined. That's hawaiitracker.com/support. We do have one sponsor that we want to acknowledge, Kaleo's Bar and Grill in Pahoa, and their new location out in Orchid Land. They got 2 unique menus, indoor, outdoor dining options. They got the takeouts. Definitely a good spot to check out if you're visiting or if you just want to get some good food and, get out and not go into the kitchen type of thing. So definitely check out Kaleo's, and we appreciate them as a longtime sponsor. All right, I think we can hop into some questions, huh? We don't have that many right now. If anybody wants to get in some more, we will be keeping an eye out. Phil already kind of took some of the questions on. So we have a few more here, though.
Right.
All right, so Sharon asks, and I actually saw this question a couple times. As the sheer weight of such a large amount of liquid lava increases, does that create downward pressure, and does that impact anything?
Yeah, it's a great question. We've seen that question come through before. The key thing to understand is that there's magma coming into the system from below, and that's what's driving the entire process to happen. So it's not like we have a limited supply and we move things from a lower level to an upper level, and then there's a hole below that we can then push down onto. It's like we're filling the lower level from below. It's overcapacity, so it kind of leaks upwards, and that's what we're seeing. So we're actually filling all of it at the same time from bottom up, progressively up and up and up. So the first thing is that there's not really a place for it to collapse into. That's the first thing to understand, right? The other thing is that there's a lot of gas that's in the lava too, right? And so there are a lot of times where we're seeing this with this crust and lava lake, where the rock when it hardens, with enough gas bubbles stuck into it that it can essentially be buoyant and rise on that. So there's a lot of the stuff that actually kind of floats more or less as well, rather than wanting to kind of push down. And this true does have a massive weight, but it's got to be comparing the density of it to the density of all that collapsed dust and dirt and stuff that's underneath that stuff in the pit post 2018, right? Which doesn't have as on average you'd expect, because it's all crushed up and pulverized. Doesn't have as much pore space down there as you have in this upper part. Those are 2 things that I would right. put out to discuss on that.
Susan has a question, and this is also a question that we regularly get. But any correlation between the increased activity at Kilauea and the large earthquakes formed this week in New Caledonia?
Off the top of my head, I'm gonna say no. There's all kinds of kind of novel research trying to tie these things together, but I've never seen anything that's been convincing to me. Linking events so far away, right, on such a short time scale. I mean, you can generally say, like I said this before, that there's a whole plate tectonics process across the globe, And yeah, we're kind of two different edges of the same plate there, and we are connected and related in that way. But it's not like something that happens in one place can propagate and affect the other. It's kind of like a two different ends of the stick there.
Right. Here's a question that we haven't had before. Elkner asks, what type of degree do you need to become a volcanologist? What schools are better for this type of career?
Yeah, great question. So you need to get, essentially, volcanology is, if you look at people working in USGS, let's start kind of that way. Most people that are working there have their PhDs, right? So that's kind of the level of education you often need to get to, is like a master's or a PhD. Of course, there are other positions that are maybe not the top level researchers that quite as much as that. So normally you need like some kind of master's degree or PhD in geology, volcanology in particular, depending on which university you go to. Offerings happen to be, right, would certainly be better. Within volcanology, there's a lot of different disciplines, right? So you could be a geochemist and get a degree in geochemistry, volcanology, a degree in geophysics and be a volcanologist. You can get a degree in deformation, right? Whether you're looking at INSAR satellite stuff or GPS, what have you, all the different things you can that as well. Like all different pathways, right? Because it's really a collaborative science with all different aspects, right? We're talking about physics here, we're talking about chemistry here, we're talking about the actual. Right. There's just a lot of different stuff that goes into it, right? Now, of course, geologists.
The edges get kind of gray when you have the scientists working on the volcano, but maybe they wouldn't consider themselves a volcanologist, type of thing.
Yeah, it's everyone has their own preference of how they think of themselves, of course, right? But like those are important things, right? Each VO has got different divisions, right? They have a gas geochemistry division, a geology division, a geophysics division, they have a deformation division, they have an electronics division.
Right.
They have like there's all kinds of management. There's more than that, but I'll leave it.
All right. Final question for this one. Mary asks, how does a lava tube form?
Man, that's one that's a lot easier when I have all the questions lined up, right? But
I know, right?
But
maybe just the quick pitch.
Yeah. So the analogy I've used before is if you imagine like a river in a cold place in the wintertime, right, that starts to freeze over on its surface, and you get that icy crust, but there's still a flow of liquid water beneath it. It's still moving, so it can't actually harden. It keeps moving through there. And lava tube form is kind of like that. The difference being that there's never a spring and that top part doesn't melt again. It essentially is encased, and the lava is then within that underground pit. So the lava is flowing across the surface of the ground. It's exposed to the air, and it's cooling and forming a crust. As that crust forms, lava is still moving within it, so it kind of pressurizes it and bulges it and kind of cracks it and moves it and swells the whole lava flow. And it's flowing through the middle of the flow there. And if it goes on long enough, it can start carving its way downwards perhaps as well, melting its way downwards and enlarging itself in that way. So some lava tubes that are the largest ones around that people could visit perhaps, like, Nahuku National Park, lava may have been flowing in there for years and years and years for it to actually get to that size. Whereas it might start off more of like a flat, kind of long shape like that, right? Carve their way down over time. Quick answer there.
Yeah. All right. Well, we will be doing one more Q&A segment. So if you got a question, throw it in the chat and we'll try and get it in. So back to you, Phil.
All right. Yeah. Let's see. I saw a couple other questions here. Maybe I just I don't know. You're addressing a lot of them in the chat, but I think there's some that are worth just mentioning here. Someone's asking, should we be worried about another Leilani eruption estates breakout anytime soon? And no evidence of anything like that. And one other one back over here.
Yeah, that one came in while we were in the Q&A. But yeah, that's a good one.
Both volcanoes erupted at the same time before. 1984, they were both active.
Yeah.
For a couple weeks there.
And times before that as well. But that's just the most recent.
Marin's asking, is the drop in tilt imply it's going to slow down again? I mean, it seems like it kind of has slowed down in the last couple of days here, and I'm kind of wondering what happens next. But the fact that the tilt's disconnected from that earlier signal is kind of curiosity, and who knows what the tilt does and what it relates to what we see in the surface. If it does do something different,
have
that'll be a clue.
We do have 2 super chats coming through. Want to acknowledge them. Sorry.
Please do.
Tim, $50, no comment. Appreciate it, Tim, for the support. And Susan, $50 says many thanks. Appreciate it, Susan. Awesome, guys.
Thank you.
Thank you. And we will collect questions for the last part, and sometimes they'll be in chat, sometimes they'll be in get into the Q&A at the end, but we'll try and get them answered one way or another.
Right. All right, so I see a question here. Does the lava crust or the rock remelt when in contact with hot lava? That's an interesting one. You know, it's something that we've talked about before, possibly if you expose it for long enough and in the right conditions. And I bring that up because I got to wonder if all these breakouts we're starting to see, I'm going to put this back on this F1 loop here from the last week, right? All these breakouts that we're seeing coming up through the middle of the crust, right? Our perimeter of our original crust is all the way back through here, and we're seeing breakouts coming through the middle here, coming through the middle here, right? A little bit out over here, and I'm starting to wonder, right? I mean, where are those weaknesses coming from through that crust? Is it possible that we're remelting some of those areas and thinning it and allowing it to come up and through? We haven't seen it happen as much over here, but there are now a lot less of these old parts of crater floor because this whole middle part's getting covered and paved over. There's like an old sliver over here and an old sliver over here, but it's getting really encroaching on the central island, and that thing is actually getting buried on its edges, it seems like, over the last few months here. So interesting to think about whether that could be happening, especially on this eastern part over there. Also,
the one that I always the one I'm looking at now is at the bottom at the bottom of the cascading pools where it's been churning. I'm just wondering how much it feels. It seems like that's some kind of super hot liquid sandpaper down there, just eroding the thing really quickly. It's just interesting, that little area, to see it kind of evolved into what it is now and maybe where it's going.
Yeah, this one, yeah. And so this is something that comes up in lava tubes as well, as this debate of the relative contributions of the actual physical erosion, the rock actually physically rubbing, right? If I took a rock and I just was rubbing it against another rock, like for every day, all day, for as long as this thing's been doing it, I would erode some stuff too, right? That's one part of it. As well as the fact that within the lava flow, you have bubbles of gas, and the bubbles of gas act like the grit on a sandpaper, right? Helping to concentrate the pressure like in certain areas, and it kind of makes it more than less and more than less. It's like that gives that abrasiveness. As well as, of course, the fact that the lava is heating and possibly remelting the rock, and if it's not remelting the rock, it could be making it more putty-like, so it can be scooped out easier. It might be a combination of the two, all of that. So it's a healthy topic of discussion there that can occur of how much melting and how much eroding is happening, but certainly both things can be important. Do you think they might zoom out the F1 like they did with the B1? Maybe. It's a good question, right? The F1 camera is getting pretty cropped there, and I mean, I kind of wondered if they, it's nice to have it never move because that helps you with the long-term time lapses. But you almost seem like you need 2 more now for the 2 edges of the thing, 1 pointing each direction, right? Or you need 2 that you need to move the one a little bit this way and then point a second one over here, so you have a wider view. Good question. We'll have to wait and see. I don't have any inside info from USGS. Did recent eruptions lead to lava tubes? Yeah, the whole Pu'u'o era had lava tubes from the rift zone at Pu'u'o down to Kalapana area towards the coast for many, many years. We didn't really see that occur as much in 2018 because we had such that big open channel. And within the summit crater here, the pathways of lava are not forming exactly the same way, so I hesitate to call them lava tubes as well, right? We could go back to the old Dr. Jack Lockwood term here and call them all pyroducts that are all pathways for this lava to move through regardless of its formation, right? So, but maybe I'll leave that kind of worms closed the rest of the way there.
All right, we will be doing questions at the end as well, so go ahead and get some more in, and we will get to them as well.
All right, so let's see. Let me get my next segment lined up here. And we're going to start off looking at the near vent changes in Kilauea. So back to Kilauea for the rest of our deep dive here. Those of you guys who are still with us, mahalo. Realize we're going a little longer today, but there's a lot of cool stuff happening this past week with no pauses and we'll look at. So here's our V1 over the last week or so. And here, let me look here so I can loop for you guys, and we'll check out a few different areas of this time lapse. So for those of you guys who maybe haven't seen this camera before, our main west vent cone complex is over here on the right. The west vent pond is over here, bottom middle, and this spillway goes off in this direction towards this main actively circulating lava point. Up. A lot of gas in that view here. So what we'll do is we'll kind of zoom into different zones. And let's start off by looking at the cone zone here. You can see that the cones are growing. They have occasional lava flows coming down the sides, spattering, sometimes from the base, sometimes from the top. It depends on whether it's along with a surge or not, but that's all happening. Pretty similar to the last few weeks here, so I won't spend too much time, but interesting to note the different profile and shape of these things every week that we look at it, right? All right, there's another separate cone in between here, closer to this west vent pond, and you can see that it also can put out flows and a little spatter. You can't quite see the opening from this side as well. And we'll pan across over here to our west vent pond. And this pond actually changes quite a bit over the course of this last week, right? You can see that just in this last jump right here, this bottom part of the pathway seems to be collapsed and opened up. So you see that compared to the beginning of this video, circulating in a small pond, it grows a little bit this way, grows a little bit more, grows a little bit more, and eventually we have a much larger open channel with a big overhang over it visible right. So that's that variation lava level and evolving this whole zone. This is the zone that we noted was growing a spatter cone here on its bottom side last week. We have during a surge, another little cone pops up right on the side of that spatter cone. And then we start to see this movement, and perhaps once again, you could be having erosion, heating, disturbance of this. It's almost like a lava tube, this crusted over pathway right here, this spillway. And that's collapsing and growing the vent area right through here. So that's pretty cool. We've looked from another angle at that lava nado that was down here at the mouth of the spillway, and we're looking up at all these vents all through here. So you can see a little bit of spatter. You see a lot of movement, some really interesting, ground movements right through there. There's one series of frames where you see like subsidence in one area and then the ground rising right next to it, right to the side. So look for that right in here. Right around that spatters up, right? To see that drops down in here and it rises up over there. And this is that spattering zone. So a lot of little minor changes all through here. The lake itself, we don't see as much changing right at that lip over there, but I wanted to point this out as a continuing development with our V1 camera. Has changed quite a bit over the last few weeks here. We've seen all kinds of cool stuff happening. Current view of the V1. Well, no, this is not a current view. This is a image from the USGS here. Looking at that area. So the pond is back over here. The spillway is right here. Here's the edge of that pond, and so here's those cones and vents, that one separate and a taller one from an opposite point of view, opposite direction here. View. So current view is here. There it is. So you see that maybe we don't see as much lava all the way back through here. Maybe the lava level was dropped a little bit or crusted over perhaps, something like that. But otherwise, it's still active down there. Okay, a couple last things here on the images. I did refer to this before, but there are a couple images here showing that on March 22nd, Kilauea Kilauea was sampled by the USGS here. So you can see them pulling up the spool of wire that they're using to lower the instrument down to the water table. And that's what this well is for, is measuring the water table. And often this is where we get chemistry reported out of the water, like how much sulfur is dissolved in the water, other things as well, so that we can follow their interpretations of how much relatively new magma is coming to the system there. So there's one view. I zoomed in, and here are the more zoomed out view where they've driven around that site. So pretty cool. We'll have to wait results. Nothing more to report there on that. But now we'll turn to our filling rates, right? And so I wanted to pull up this map back from last year, April 5th, because it's pretty good in showing these contour lines, right? So at this time, last year, lava was still within that innermost pit, and we had a green line here at 800 meters elevation as the edge of the inner pit. We've now reached that and exceeded that, right? But I want to point out that's the 800 meter contour right there. The 900 meter contour is in purple right through here, and that's the edge of this down drop block kind of over here. I zoom it back out, right? This big area right through here, that's 900. So once you get above 900, you can spill out into this zone here. You're restricted within there until you get to this next blue line, which is 1060 meters above sea level. This is about the edge of the rim of the collapse from 2018. Right, so those are the different levels that we're considering there, right? Is that the most recent map we have from the USGS? I think we'll get a new one here in the next few days, if not early next week. We're showing that lava is now at the 836 meters above sea level mark, actually 839 by today. So that if I zoom it in, you actually can see that compared to that last plot with this lava extent more or less like that, we were quite a bit wider to the sides, and we have this big wing up here in the north, and we're starting to form this little wing down here as well, right? It's second cat ear coming through pretty soon. Okay. Also wanted to point out that there is this larger caldera all the way through here that's all the way around like this. Goes kind of right like that, right? So there's a zone more or less down in here where the lava could spill out of the caldera if it fills it up eventually, and that's a point that we've considered in the past and refer to it once again here as well, right? So that's that southwest spillover point of the caldera is down over here. A little bit of reference for what we're talking about. So because the last month has had two different filling rates, what I've chosen to do here is to calculate it using both and give you guys a range of it, right? So if we use the rate that we had earlier in the month, 3.2 cubic meters per second, what I'm showing here is elevation above sea level on the left. So we're currently at this about 840 or so, right in there. Here's a history of what happened before the eruption. This is the collapse elevation from post-2018. That eruption that occurred in 2020 to 21 filled it up that far, and then kind of through here, this was its gap, the pause, between eruptions. The next one began, and we've come this far, right? So this is what's real, and its plot is just this much. That's what's actually happened. Everything else is a projection here with a date on the bottom. And this is 1 year, right? So 2021, 2022, 2023, beginning of each year here. All the way to, you can see, 2028. So at this lower rate, 3.2 cubic meters per second, we can expect the lava to hit that downdrop block by the end of this year. Perhaps December, perhaps a little earlier, perhaps it all depends on that rate, which is never exactly the same. This is just the assumption we have to make to kind of pick any numbers out. So we're looking at it could fill to spill over into that downdrop block by the end of the year. It could reach the elevation of that highest point of the lava lake in 2018, which is a little over 1,000 meters, somewhere in 2025. Right? As you guys are wondering about how high it could come at that point. For it to go onto the main caldera floor at that rate, it would take it close until 2027, into 2026 or so, right? So we're talking about 4 years out, right? And for it to actually spill out of the caldera on the southwest rim would be 2028. So we're looking at 6 years out at this lower rate, right, of actually filling the whole caldera, assuming lava doesn't change its plumbing, go anywhere else, anything else, but it keeps going non-stop, right? And here's how much we've come. This much is at 60 million cubic meters, and that's a long, 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 long way to go, which is why it would take so long. The faster rate, 6.1 cubic meters per second that we've seen in the last 2 weeks here, that moves it up by half, right? So instead of looking at 6-year timeline, it's a 3-year timeline. If you could keep this rate up for 3 years, then yeah, you could fill the entire caldera and spill it out the southwest rim. Right? At this current rate, we would get to the down drop block here probably at the end of summer, it looks like, rather than end of the year. So that's kind of the pace that we have to figure out what it's gonna be here next few months. So 840, that's where we are right now. That's about 2,750 feet elevation above sea level. So how does this compare to the historical stuff? So I pulled a couple of pages out of USGS professional papers. This one's from 1806, and don't be scared of the graph and all here, but what we're looking at is the red line is showing the elevation of the lava lake historically. So we're looking at all the way back to 1894 and all the way to 1913 in this particular plot. And you can see that there's a lot of inaccuracy from visual measurements here, but you kind of get an idea of where the lava level within the lake happened to be. So, we unfortunately on this paper have elevation in feet, but I just mentioned that we were at 2,750, so like we're currently more or less right in here, right? So it happens to be this level of collapse that came to be in 1899. Followed lots of times beforehand, and we don't have as good data, but lava was way up before that, like spilling over and erupted, collapsed, bunches of times. And so better record we have comes in here in the beginning of the 1900s. So we could consider as an example from this era of, we'll call it 1902, when lava was visible down here at about the same elevation as we have today, right? And the reason I like this particular comparison is that the caldera in this age had not filled all the way up, and so it was still a wide bowl. It wasn't a narrow neck. It was a wide bowl, and so when it's filling is having to spread out like we have today. And that makes it probably more comparable. So in any case, lava was down at this level in 1902, and you can see that it wasn't continuously witnessed, but that it reached this level of 3,000. That's about the down drop block at 900 meters. In 1904, that's 2 years. That's how long it took, that era. And it actually kept going. You can see it reaches up to this 3,000 meter elevation, which is about the caldera floor, about around at 1060. Or sorry, that's the top of the 1060 elevation or so. In 1908, that's about a 6-year timeline as well, right? So interesting to note that this kind of pattern is not very good data, but it's something like this possibly has happened before, over 100 years ago. And then the lava lake varies quite a bit, goes down. I'll show you guys the next frame of this, right? And now it goes from 1912 to 1926, and really once it gets past 1917, right in here where the lava reaches that upper rim of the crater, then now you no longer have a big shallow bowl, and now you have that narrow collapse pit. And so from here on out, we're going to not compare it as much. But scroll it over here. Right, 2750 would be down around here, so we're still way below this, but you can see the variation in lava level that's occurred in the past has been largely above where we are now, except for those times way back, early 1900s. So that's the first comparison I make. Okay, not to dwell too long on that, I'm going to skip ahead to 2018. This is a plot of the 2008 to 18, so 2008 eruption onset right here, and collapse 2018 end of lava activity right there, right? So now we're back to meters. Meters of lava lake surface elevation here on the left. Crater floor is right there. The actual caldera floor is a little higher up here. Right, so when eruption was first, the first plots on here, when it was first noticed in mid-2009, compared to the crater floor, they were putting that value somewhere, we'll call it maybe 825, 820, maybe 815. That's the range of meters above sea level that lava was first spotted within that pit, 2008 and 18. Now, it's worth noting, like I just mentioned, that it was a very, very narrow pit, and it wasn't the whole wide bowl. So now we can't compare the rates of it rising anymore, but we can compare the elevation that things are at, right? So we are currently right now the elevation of 840. We're more or less right in here. So we're essentially looking at the lava level where it was in the bottom of that pit when that opened in 2008. And from 2008 until mid 2010 or so is more or less in that range right in there. So to give you a better idea of what this looked like, I've dug out this old video. And then some more from January 7th, 2010, thermal image. They're flying over the deep pit and they're looking for lava down there at the very, very bottom. And it kind of, as they fly over this thing, eventually you see at the very, very bottom of this massive shaft, there is a lava flow way, 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 way down there. And this gives you some idea of the difference from that to now. Right? So I talk about it being a narrow throat and the filling rate and that kind of geometry is different from what we're talking about with the whole caldera being available. January 13th, a few days later, not flowing as much, but there is where the degassing is going on with lava at the very right. So now you know what we're talking about there. Actually, early on, set on me here. Early on here, through infrasound studies, right? They're doing resonant frequencies. They estimate that the gas is vibrating at those frequencies because of being a certain depth below within this cavity right there. And so they've modeled this out, and in this particular cartoon is 217 meters, and other ones it's 219 meters. And compared to, we're now a professional paper 1867A, which is a recent one about the 10-year lava lake at Halemaʻumaʻu. But they note here that the orbital crater rim at the time was 1023 meters above sea level, right? And that they detected about 200 meters below there, or that 219, puts it closer to 800 meters or so, 804 meters above sea level or so. So we may have passed that point a while ago. Here's a picture of what that looked like at the time. Right? It was deep in that pit, way down there, right there. And they actually were able to do LiDAR scans at the time. So here's a LiDAR scan showing the overlook zone right here. Here's that main crater of Halemaʻumaʻu with its floor, and then that pit within it. And this part blocked from view, so it probably is actually more like this. But actually, the important part here is this 206 meters measured by LiDAR. Right? Not acoustic anymore, but by LiDAR, once again. Consistent numbers. 206 puts it at about that 825 above sea level, so or a reverse view. Now, in 2011, there's a collapse of the crater. Lava withdraws once again. They're able to scan it once again. At this point in time, they actually see lava residual kind of, at the bottom of this collapse pit here, but it's down 260 meters down. That's a long, long way down. So at this point now, I want to go back to our plot over here, right, and look at this value, which is right over here. That's at 260 going down right over here. Right, this is the collapse of that pit, and it's hard to tell if it's collapsing, if there's lava down lower than it might normally be. But kind of have two different patterns of elevations here. One is the collapse, which is down here, and the other is the kind of the high points right through there. Right, so you can see that the main trend is it was rising, 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 and then kind of stabilized at that high value, and then rose and overspilled kind of off through there. The collapse points, right, we know that the collapse point was probably pretty similar to right in here. So kind of call this as down, down, and if I scroll all the way to 2018 to the right side of here, we actually have a point much, much lower down. It's close to 700 meters above sea level, right over there. And so we actually passed that during that first eruption. If you're want to look at the bottom end of where the lava has actually been, so there's that. So that's the 2011 profile right there, and then in comparison, here's 2018. 2011 is right there. That 2018 was bigger, and this was May 9th, and of course May 9th things didn't stop. Things kept collapsing for 2 more months after that, 3 more months after that. So this is only like a picture moment in time, and there is a lot else going on here, which is the whole bottom of the caldera falling out. So when Dr. Caroline Parchetta sees lava on May 9th, 2018 at the bottom of the pit, way down there, right? At the elevation that's they're saying is 330 meters below the rim. It's the lava still in that lake, but the whole bottom is falling out. That's kind of a special case thing there. So I'm doing all this to really refine my answer, give a better, more correct answer to what we said last week when we were talking about what is the lava level now compared to the lava level of the lake before. And when I answered the question last week, I was essentially saying, okay, well, the lava level before, when you could see it from overlook, that's kind of up in here. And that's what I use for my answer. But today, I'm giving a range, right? I'm saying the high lava level was all the way up here. The low lava level was, we'll call it right in here, right? If we don't count the collapses. And that range is something that we can look at on our plot and our projections right here as something that we've passed already, right? There's a whole range of lava lake. So we're into it now, into the era of like not the collapses, but the more normal stuff being in the same elevation of lava as we had before. The difference now is, of course, if it spills to that spot, it's going to fill out all that stuff to the side, spread out. It can't just come up that straw. So that's our projections, the filling nuances there. There's one more thing I wanted to discuss today, which is just the volcano watch from this week from USGS. The 2018 eruption, which discussed the collapse here, it was a huge collapse at the summit. Did not collapse the whole caldera, maybe a third of the caldera footprint. But on a global scale, the amount of lava that came out down in lower Puna was very, very noteworthy. So I won't read this all. This is posted on hawaiitracker.com. There's Ahu'aila'au, also known as Fissure 8. That's source of most of the lava during the last 2 months of eruption, 2018. And I'll pull out a couple highlights here. The high-end estimate is 1.4 cubic kilometers or 0.34 cubic miles as far as how much lava came out in 2018. Now, if you imagine that as a big cube sitting in the ground, that's 0.7 miles tall, or 3 times as tall as the Empire State Building. For island Hawaii residents, this is about 27 times as tall as Bay Shore Towers in Hilo. Very, very huge amount of lava. And kind of comparing it to the tower in Hilo is not really fair to the tower in Hilo, right? It's just not even anything near the same kind of thing. So they're going to compare it to other kinds of eruptions, right? So in Hawaii, the largest eruption in recent centuries was Pu'u'o, which produced 4.4 cubic kilometers, 1.1 cubic miles. However, that lasted 35 years compared to 4 months. And so this is the other part that I'm going to pull out here, and this is going to be our take today on this article, is how long does it take to erupt this amount of lava from each of these places? So 2018 was noteworthy. It was only 4 months, right? Really, it was kind of 3. Pu'u'o was 35 years to put out that larger amount. Pu'u'o destroyed 215 structures compared to over 700 destroyed in 2018 eruption. Other flows in Russia and Iceland. There's that one in Kamchatka, 1.5 years, 2 cubic kilometers. In Iceland, 6 months, 1.4 cubic kilometers. Both of those had flanks and collapses. Canary Islands, Lanzarote, 2 cubic kilometers. That one lasting 6 years. No recent estimate for La Palma, unfortunately, so we can't really compare there. We do note 3,000 buildings destroyed in that eruption. That was really massive, massive impact. Mexico in 43, 1.6 cubic kilometers over 9 years. Right, all those are essentially smaller per the amount of time than Kilauea. The one that's in a class of its own, of course, is the Laki eruption of Iceland in 1780. 8 months. 14.7 cubic kilometers, 3.5 cubic miles. Covered the landscape, put out poisonous gases, killed livestock, crops, led to famine. It was a mess. Yeah, back in the late 1700s. So this is only a compilation of kind of historic ones, and so I'm gonna actually click over here to their Twitter post. Yes, I hope it loads here. Yeah, so it actually lists it all nice in this table. So Kilauea, 0.34 over 3 to 4 months. Right, all these other ones of similar volumes were all over more months or years. Right, Pu'u'o, we noted, was over 35 years. Laki at 8 months. That's the one it really compared. Right? So really, in this list, if you're considering it of eruption rate, right, of the large eruptions, how much is coming out, how fast, Kilauea comes in a solid second right here.
I remember 2018, at the time of the eruption, we were comparing Babashunga to Kilauea and that Icelandic eruption and the caldera collapse, because it was kind of the best analog we had, even though the caldera collapse there was underneath an iceberg. So we didn't get to see it. But glacier, sorry, yeah. Glacier. So we didn't get to see it other than the deformation and the signals, but no the physical site other than the rift zone eruption that corresponded with that collapse.
Yeah, and of course, uncertainty that occurs exists because of all the lava that went offshore underwater, and of course, we have the Nautilus data that's backing that up. But there's still uncertainty there, so even with the uncertainty, Kilauea is up there, and of course, the difference being that many of these other eruptions did not occur in inhabited areas. So not only do you have this massive, historically significant rate, it's happening in an area that's inhabited. Like that was like that perfect storm, so to speak. Why we still talk about 2018 and probably will the rest of our lives. So that's kind of the context of that. Of course, that collapse at the summit was just the beginning part of that. We'll end here by showing you guys this time lapse from the west, the Kīlauea camera. We close it out for you guys here and look at our last round of questions here. So hopefully that we did cover a lot. We're going to go a little longer than we have recently. Still with us, so you get this bonus time lapse here. And it again and look for some questions, Dane.
All right. We only got a couple here, but we will get through them. One of these we've done before, but we're on the new day. I think new viewers are coming in, so we'll happily take some of these questions. So, do you think the increase in earthquake activity around the Ring of Fire might have some contribution to the eruption changes on Kilauea?
No, we don't think so. It's kind of all part of the same giant conveyor belt that's the size of the whole Earth. But in a short term, you don't see the processes in one place affect other place, really. Right? They're both likely to happen independently, and sometimes they happen together at the same time. That's all there is to it.
Janelle asks, I may have missed it, but is there a significant amount of gases being released for us that have breathing issues? I assume that's on the Kona side.
Yeah, so the gases coming out they're still coming out. There haven't been any pauses the last week, so the gas has been more constant, right? The amount of gas over the whole week is probably more than the previous weeks because there was no pause until possibly right now. And not only that, the value measured was slightly higher this last week as well, but it comes down to 3,000 tons per day, which is kind of quote unquote normal for the range of the volcano. Yeah, so it's kind of,
all right.
The range back in 2008 to 18, and I want to say it was between 2,000 and 4,000 per day, so we're kind of in that same ballpark once again right now.
All right. Got one final one. Kenny asks, how long until Big Island is completely covered in lava?
It's already completely covered in lava, I suppose. Is really my answer to that. Yeah, good one, right. Kenny. Yeah, I don't have a good answer, so I'm making a joke out of it here because, the active volcanoes are on the south side. The ones on the north side are less likely to erupt, right? Mauna Kea likely still will at some point, but Kohala not so. So can you cover Kohala? One of the others?
What's the stat on the Kilauea and Puna? Wasn't it 90% of Kilauea will resurface itself in, what was it?
Yeah,
I'm trying to remember the year gap. 1500, I want to say.
The last 2,000 years. Yeah, in the last 2,000 years.
Okay, 2,000.
90% of Kilauea has been covered.
Right. So that's a stat.
But that's
that's just Puna.
Yeah, that's the active part of the island. So yeah, I mean, and there are other parts like Waialae is not covered nearly as often, and you're not going to cover all of it ever really at the same time, right? You're kind of past that part of it. So my joke answer is, of course, everything was lava, liquid at some point everywhere on the island, and it's just a matter of when it stopped flowing, right? Is the other way to look at it, to kind of turn a question on its head.
Right.
So
yeah,
otherwise,
interesting.
Maybe it's not going to cover the whole island.
Yeah,
it'll cover this.
Fast forward 100 million years or something, and part of the island sinking, and we only define Hawaii Island as a very small segment of maybe then type thing, but I don't see it
Right, 100 million years
I
is
just
a
don't
long
see it.
time, right? Like the whole archipelago is like that's like Hawaii's gonna be under Kamchatka.
There's gonna be a lot of changes.
Right, yeah,
Yeah.
that's but yeah, a million years. We could see some.
Something maybe.
Yeah.
Yeah. All right. Well, that does it for questions. We will be back next week at our regular time, which is Thursday, 5 p.m. Hawaii Standard Time. Hope to see you guys then. Check us out on the Hawaii Tracker Facebook page, hawaiitracker.com. Like, share, subscribe, all that jazz. Really does help out. And we will see you next week.
Thanks, Dane. Thank all you guys for joining in. I'm just trying to catch up on some of these comments here. Thank you guys. You guys are super active. It's hard to read them all. That's great. I'll catch up a little later. Yeah, thanks once again for joining us, and we'll be back on Thursday, as Dane says. Like, share, and subscribe. Haven't already. Feel free to submit questions to us. Like, I haven't been as good about answering the questions after the videos, but I'm gonna try to get back on that here and try to get this conversation on the videos going after we finish our lives, because that does help the algorithm, as Dane said. So feel free to drop your questions on there, and you feel free to pester us online on those same things to bump us to get to that answer.
Right. Yeah, definitely. All right.
All right. Until next week, from HawaiiTracker.com, he's Dane DuPont. I'm Philip Ong. Aloha, everyone.